Hey everyone, this is Tyler Berry back for another whiteboard session. So today we're going to talk about adiabatic humidification. And one thing I want to cover real quickly is obviously the difference between adiabatic and isothermal humidification. So just to review the site chart real quick, in traditional isothermal humidification we actually have a slight uptick in temperature rise with humidification because we're using atmospheric or pressurized steam. Sometimes it's going to be a degree, 2 degrees, up to 5 degrees, depending on what we're using in terms of atmospheric or pressurized steam. Now with adiabatic humidification, we have humidification and cooling at the same time. So we go over here like this on the site chart. What does that mean? We can get up to 10 to 15 degrees of cooling. This is great application where you have a lot of humidification loads in shoulder seasons and into the summer where you need that benefit of additional cooling and humidification at the same time. There's several different ways to achieve this through a number of different technologies. You have high pressure atomization, where we're using pressurized water RODI feed at like 1200 psi. It evaporates into the airstream really quickly and we get that supplemental cooling. They have ultrasonic humidifiers where you have these ultrasonic rotating discs, really good for small loads, but also require RODI feed. You have wetted media. So this is wetted media where you cascade water over top of obviously wetted media. Now the good thing with these is they're really energy efficient but require really constant loading because this is a big wet sock. And what do big wet socks do? They stay wet. So large varying loads don't fare well with wetted media. So let's talk about high pressure atomization for a second because it's really big nowadays, especially in labs, especially for all sorts of different applications, because it's really an energy efficient way of doing things. But it requires RO or DI feed. It requires a lot of length in air handling units or ducts just due to evaporation distance and efficiency gains. And also, if you're only doing cooling humidification in the winter, do you really need 10 to 15 degrees of cooling and then pay for that reheat? It all matters on efficiency. It all matters on dollars and cents when it comes to energy. So what makes a good application for high pressure atomization? Well, you need at least pretty much 2 of these 3 criteria. You need the benefit of cooling and humidification at the same time. The benefit of zoning. High pressure atomization is 1200 psi water. Think of it as a VAV system with fans. So you can have multiple zones and multiple levels of humidification on one system with a 5-10 horsepower motor doing the entire thing, up to several hundred pounds, several thousand pounds worth of load. Also, like I talked about, large capacity humidification. You need 5,000 pounds an hour worth of humidification on a 10 horsepower pump. That can pretty much do it. But you need 2 out of 3 of these to really make sense because, you know, at the end of the day, if you're doing a high pressure atomization system on 100 pounds per hour, is it worth the investment on the piping, the complexity, the maintenance of these systems when you're doing that? So some applications that are really good for this is data centers, archival storage, industrial manufacturing, and universities. All these things have specific applications, and really what it matters is the cost of electricity, the cost of utilities, and the scale of the project. Now, we work together with Dry Steam to make sure we evaluate each project specifically or what's the best fit for high pressure atomization. We even have some opportunities to do some energy evaluations on each specific project based on the building type, based on the loading, based on the time of day, all those things. So it's something to keep in mind. Appreciate your time. If you have any questions about adiabatic humidification or isothermal, reach out to us. I appreciate your time.